Imagine being stranded in the middle of the ocean. No GPS, no landmarks, just endless waves stretching to the horizon. The stars are hidden behind thick clouds, and the sun has long set. Without any way to tell direction, where do you go? For thousands of years, sailors faced this terrifying reality. Some never made it back. Others drifted for days, hoping to find land. But everything changed with one simple yet revolutionary invention: the compass. The compass isn't just a tool, it's a game changer. It allowed humanity to navigate uncharted waters, fueled exploration, and even laid the foundation for our modern technological world. But where did it come from? How does it work? And why is it still one of the most important inventions in human history? Let's embark on a journey to uncover the story of the compass. Our story begins over 2,000 years ago in ancient China. Around the 2nd century BC, Chinese scholars noticed something unusual about a naturally occurring mineral called lodestone. This iron-rich rock had a strange property. It always aligned itself in a north-south direction when freely suspended. To the people of the time, this was more than just a curiosity. It was a glimpse into the unseen forces of the world. But here's something fascinating. The first compasses weren't used for navigation at all. Instead, they played a role in fortune-telling and feng shui. Ancient Chinese geomancers or diviners believed that aligning structures with Earth's forces could bring balance and prosperity. Lodestones were used to determine the most auspicious locations for homes, temples, and even grave sites. It wasn't until centuries later that the true potential of the compass was realized. By the 9th century AD, Chinese inventors had refined the design, creating the first practical navigation compasses. Instead of relying solely on floating lodestones, they discovered that rubbing an iron needle against lodestone magnetized it, giving it the same directional properties. When suspended or floated in water, this magnetized needle consistently pointed north. This breakthrough marked the birth of the first true compass. At first, the compass was a closely guarded secret of Chinese mariners. But as trade routes expanded and cultural exchanges flourished, this knowledge made its way beyond China. By the 11th century, compasses began appearing in the Islamic world and then in Europe. Arab navigators, known for their advancements in astronomy and cartography, improved upon the Chinese design by enclosing the compass needle inside a protective case, making it more reliable at sea. European sailors quickly recognized the power of the compass. Before its introduction, navigation relied heavily on the stars, the sun, and coastal landmarks. But what happened when the skies were cloudy, or when ships ventured far from shore? The answer was often disaster. The compass changed all of that. By the 12th and 13th centuries, it had become an essential tool for European explorers, setting the stage for the age of exploration. Without the compass, history as we know it would look very different. The great voyages of discovery, Columbus crossing the Atlantic, Vasco da Gama reaching India, and Magellan's circumnavigation of the globe, were all made possible by this small but powerful tool. It enabled explorers to travel farther, map new territories, and establish trade routes that shaped the modern world. The impact of the compass wasn't just about finding new lands, it changed economies, geopolitics, and even science. Empires rose and fell based on their ability to navigate the seas. The spice trade flourished, connecting Europe, Africa, and Asia like never before. Cities such as Venice and Lisbon became global trading hubs, and as ships carried goods, ideas, and people across vast distances, the world became more interconnected than ever before. But how does this simple device actually work? The secret lies in Earth's invisible magnetic field. Our planet itself acts like a giant magnet, with magnetic poles near the geographic north and south poles. When a magnetized piece of metal, such as a compass needle, is allowed to move freely, it naturally aligns with Earth's magnetic field, pointing toward magnetic north. However, there's a catch. Magnetic north and true north are not the same. The difference between them is called magnetic declination, and it varies depending on location and shifts over time. Early navigators had to constantly adjust for this discrepancy, and even today, scientists track changes in Earth's magnetic field to keep navigation accurate. The importance of the compass wasn't limited to exploration. Armies quickly saw its potential. In medieval warfare, compasses helped commanders plan strategies, navigate difficult terrains, and position troops for battle. By the time of World War II, compasses were essential for soldiers fighting in unfamiliar environments, whether deep in the deserts of North Africa or the dense jungles of the Pacific. Even scientists benefited from the compass. It played a crucial role in early geology, helping researchers map magnetic anomalies in the Earth's crust. This eventually led to the discovery of plate tectonics, the very process that shapes our planet's continents and earthquakes. Fast forward to today, in space, traditional compasses are ineffective. Spacecraft navigate using gyroscopes and star trackers to maintain orientation. Additionally, magnetometers analyze planetary magnetic fields. For instance, NASA's Mars rovers use them to study Martian geology. With satellites, GPS, and digital navigation systems, you might wonder, do we still need compasses today? The answer is a resounding yes. In fact, you probably carry one with you right now, inside your smartphone. Modern smartphones contain tiny magnetometers, which function like digital compasses. These sensors detect Earth's magnetic field, allowing your phone to determine its orientation. Without them, your GPS wouldn't know which direction you're facing, augmented reality apps wouldn't work, and even basic navigation tools would struggle. Every time you use Google Maps, play an AR game, or check your location, you're using a digital version of an ancient invention. Beyond smartphones, compasses are still vital in aviation, space exploration, and even medical technology. Did you know that some robotic surgeries rely on tiny magnetic field sensors for precise movements? The same principles that guided sailors centuries ago are now helping doctors save lives. But there's one modern challenge. Earth's magnetic poles are shifting faster than ever. The North Magnetic Pole, once relatively stable, is now moving toward Russia at an alarming rate. This movement is forcing scientists to update global navigation models more frequently. Pilots, sailors, and even self-driving cars rely on accurate magnetic data to function properly. If the poles continue shifting, will we need an entirely new way to navigate in the future? From ancient Chinese lodestones to digital sensors in our phones, the compass has been guiding humanity for over 1,000 years. It led explorers across oceans, helped armies plan their battles, and now assists astronauts in space. Its evolution from a floating piece of iron to an advanced digital tool proves one thing. Sometimes the simplest inventions have the greatest impact. So the next time you check your phone's GPS or see a compass icon, remember, it all started with a small piece of magnetized metal floating in a bowl of water, pointing the way forward. If you enjoyed this deep dive into the history of the compass, make sure to like this video and subscribe for more fascinating stories about inventions that shaped our world. See you in the next one.